Here we go, section 2.6, geometric proof. So we're really getting into kind of what the meat of geometry is here in two-column proofs. And this is something that not everybody enjoys doing, but I think it's important to be able to reason your way through something and show why something is the way that it is. So our objective for today, I can write two-column proofs and I can prove geometric theorems by using deductive reasoning. We've already talked about deductive reasoning, so let's take a look. When writing a proof, it's important to justify each step. So we have to justify, we have to say why each step is true. You can use symbols, abbreviations. They have to be clear enough so that anybody can understand them. So you can abbreviate, that's fine. Just make sure we can all abbreviate, or we can all understand it. So you start with your hypothesis, and like I said, definitions, postulates, properties, theorems, those are what you're going to use to be able to then say your conclusion. So it's kind of like showing your work during an algebra problem, but instead we're justifying our thinking as we go along. So we're writing a justification for each step. It's given that A and B are supplementary. Okay, so A and B are supplementary, and the measure of angle A is 45. That's our given. We just put given for that. After that, where we can go is because they are supplementary, we can say that they add up to 180. That is the definition of supplementary. Then we can substitute. And we're substituting, we're replacing the A in step 2, right? We're replacing the A with the 45. And then finally, subtraction property of equality. Remember, that means we subtract 45 from both sides and we get our answer, which the measure of angle B is 135. And that's what we're looking at here. So if you look here, they give you a helpful hint. When a justification is based on more than one previous step, you note this after the reason. So you see that right there with our steps 1 and 2. That's saying we are substituting using step 1, which is A is 45, and step 2, which is this statement. And all we're doing is replacing this with the 45. And you see that in the next step. So we're going to try another one. They give us the steps. We just want to write the justification. B is the midpoint of AC. Well, we know that that's just our given. Right? It says right in there, given that B is the midpoint. AB is congruent to BC. Why can we say that? Well, we can say it because it's a midpoint, which means that's our definition of a midpoint. If something just is, chances are it's because of a definition of something. So now why can we say that AB is congruent to EF? Well, if you look up here in our little paragraph here, that's given. Okay, given information. Again, we just write given. And so our last step here, why can we say that BC is equal to EF? That's our transitive property. Remember, transitive property says if A is congruent to B and B is congruent to C, then A and C are congruent. So transitive property is what says that BC and EF are congruent. We're looking at theorems now, which is any statement that you can prove. So we have to prove that something is true. That gives us a theorem. First theorem that we're going to talk about here is the linear pair theorem. It says if two angles form a linear pair, then they are supplementary. Okay, this kind of makes sense. Remember, a linear pair, the non-common side of the angles are opposite rays, and they are adjacent. Okay, that's what a linear pair is. So if we have a linear pair, now, right away, we can say they are supplementary, that these two add up to 180. Once we have looked at a theorem, we can simply use that theorem in our proofs now. We could use linear pair theorem. So anytime we see a figure like this with angle 1 and 2, which are linear pairs, we can now say that angle 1 and angle 2 are supplementary because of the linear pair theorem, which would be our justification. Next one is congruent supplements. If two angles are supplementary to the same angle or two congruent angles, then the two angles are congruent. So what this is saying is if I have angles 1, 2, and 3 here, if I know that 1 and 3 are supplementary, so let's say this is 40 and this is 140, so I know those are supplementary, and then I also know that 2 and 3 are supplementary, which that would make this 40 and 140. If 1 and 2 are both supplementary with the same angle, then they have to be congruent. So they're both supplementary with 140, which means these two have to be congruent to each other. Geometric proof begins with a given and proved statements, which restates the hypothesis and conclusion. In our two-column proof, that's what we're starting today, two-column proof, you will list the steps from in the left column and the reasons in the right. So if we take a look at that, the first one should be pretty easy here. The reason is that it's given. Well, if you look up at the given, right, the only thing that's given is xy, right? That's our given. xy is equal to xy. Well, let's take a look at why that is. We said xy is there. reflexive property of equality. Remember, anything is equal to itself. That's reflexive property. So once we have that, simply our last step is the proof. It's whatever we're trying to prove. So xy is congruent to xy, and they tell you the reason. It's a definition of congruent segments. So you'll notice that we're looking at, from the given to the prove, steps and justifications. Here's another example. Let's try to fill in the blanks here. First one should be easy because it's the given, right? The given is 1 and 2 are supplementary, 2 and 3 are supplementary. There we go. Now you'll notice that from there they use the definition of supplementary angles to say that 1 plus 2 is 180, 2 plus 3 is 180. Okay, that's the definite, that's what supplementary is. So we use that. Step 3 is substitution. Well, we're going to use step 2 in that substitution. Since they're both equal to 180, we're going to set them equal to each other. Okay, we're substituting basically the 2 plus 3 in for the 180 up here. 2 is equal to 2, reflexive property of equality. That's something we know. 1 is equal to 3. Why can we say that 1 is equal to 3? Well, that's our subtraction property. Because if you look at our B here, we have 1 plus 2 is equal to 2 plus 3. Well, if we subtract 2 from both sides, we're left with measure of 1 is equal to measure of 3. So if 1 is equal to 3, now we can go from equal to congruent. That's the definition of congruent angles, to say 1 is congruent to 3. It's going to take a little bit of time to try to figure out how these two columns work, but this is just our intro to it, so do the best you can. Before writing the proof, you should plan it out, right? Sometimes you'll be given a plan. We'll look at that in a second. Here are two more theorems for us. Right angle congruence. This one should be pretty basic, self-explanatory. All right angles are congruent. So if you know you have two right angles, we can simply say that they are congruent. 264 congruent complements, very similar to congruent supplements, only now it's if they are complementary to the same angle, then they are congruent. Helpful hint for you, if a diagram for a proof is not provided, draw it. Okay? When in doubt, draw it out. And then just mark the given information on it. Just remember, do not mark the information in the proof statement on it. We haven't proven that yet. You cannot add that onto your drawing yet. So here we go. This one gives you a plan, and they want you to prove that 3 and 2 are supplementary. So our plan says use the definitions of supplementary and congruent angles and substitution. So it's giving us three things there to look at. We want the definition of supplementary, congruent angles, and substitution. That sounds like 3 steps to me. Now that's not going to be the first 3 steps because our first step is always the given. So our first step is going to be the given. 1 and 2 are supplementary, 1 is congruent to 3. Then we can use supplementary, congruent, and substitution as our next 3 steps to show that 3 plus 2 is equal to 180. Then, by the definition of supplementary angles, there's step 5, 3 and 2 are supplementary, which is what we're trying to prove. So if you look at that, like we just said, our given is first, then they told us, they said definition of supplementary angles, definition of congruent angles, substitution. And then finally, our last step was that definition of supplementary once again. Notice that definition of supplementary allows us to go from the fact that they are supplementary to they are equal to 180, and it also allows us to go from they're equal to 180 down to they are supplementary. Okay, so we can go back and forth with those definitions. Same thing with definition of congruent angles. In this case, we went from they are congruent to they are equal, but the last example we went backwards. We went the other way. We went from they're equal to they are congruent. So we can do that both ways with our definitions. Okay, so think about this plan. Go ahead, try it out if you want to, and think about how we are going to write this 2-column proof based on this plan. So if you look, we have measures of complementary angles add to 90 by definition. So they're saying definition of complementary angles. So first is our given, right? We know that. First is our given, which is they are complementary. That's step 1. Then the measure of complementary angles add to 90. So that's definition of complementary. There's 2. Use substitution. So there's 3. Use the subtraction property. There's 4. And definition of congruent angles to conclude that 1 is congruent to 3. So if you look for those reasons in your plan, that kind of shows you step by step what you're going to do. You just can't forget about that given. So if we take a look, like we said, the given, and we said definition of complementary, substitution, reflexive property, subtraction property, and then finally definition of congruent angles. So we're going step by step based off that proof. Here's your quiz. I want you to pause it, try it out, see what you can do, come on back, see if you got it. So let's check out our justifications. First of all, it's given, right? They gave it to us. Secondly, why can we say that 1 plus 2 is equal to ABC? That is our angle addition postulate. We're adding the two parts together to equal the whole thing. Now, why can we say the next one? Well, that's substitution, because all that we're doing here is we're taking the fact that measure of angle 1 is equal to 4 times the measure of angle 2, and we're replacing the measure of angle 1 with that. We're replacing it with 4 times the measure of angle 2. Our next step, we're simplifying. We're just combining like terms here. Measure of angle 2, don't think of m as a variable. M is just measure of angle 2. Think of that as one thing, angle 2. So we have 5 times the measure of angle 2 is equal to 90. Division property of equality gets us where we need to go. Last one, here's your plan. Write out your two-column proof. See if you got it. Okay, of course, step 1 is typically our given, and our given also includes the picture in this case. Okay, the picture is our given. So we can say that 1 and 2 are supplementary, 3 and 1 and 4 are supplementary because they form those linear pairs. So that is linear pair theorem there. Now, because they are supplementary, well, it tells us right there, right? Use linear pair theorem to show that the angles are supplementary. That was step 1. Then use the definition of supplementary. Here's step 2. Definition of supplementary, they're equal to 180. And then use substitution. If they're both equal to 180, they're equal to each other. And that's what we were trying to prove. So that's our entire two-column proof. So hopefully you're okay on 2.6. Remember, this is an introduction into two-column proofs. By no means are you going to be great at it after just watching this video or just doing this section. It's going to take sections and chapters and days and weeks and months even to figure out and to feel comfortable with two-column proofs. But you will get there, I promise you. So hopefully you're good on 2.6. If you need to, watch it again before you move on to 2.7.